Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss your Module 5 homework assignment. As usual, we shall use technology to solve the problems. I encourage you to take some notes as we discuss some of the questions in this assignment. You might need to take some notes down as well. The technology that we shall use would be the calculator on my website and also the Pearson Statcrunch. So, question 1. Determine whether the following sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative. A researcher wishes to compare mental health of married mathematicians and their spouses. She obtains a random sample of 319 such couples who take a mental health inventory and determines each spouse's mental health. So, from here we have like two events here. She first of all takes a random sample of 319 couples. The couples are married mathematicians and their spouses who take the mental health inventory. Then from there, she determines each spouse's mental health. So you ask yourself, can the second event, so the first event is taking the random sample of the 319 couples who took the health inventory. And then the second event is determining the spouse's mental health. So you ask yourself, can the second event occur without the first? Okay, so when you talk of dependent or independent, you look at the two events. If any of the events cannot occur without the other one, then you're talking about dependent events. But if both events can occur independently, like one does not have to depend on the other, then they are independent events. In this case, you would notice that she cannot do the second event, which means she cannot determine the spouse's mental health first without having to, first of all, select the couples that took the mental health inventory. As such, we see that the second event is dependent on the first event. So we can now say that the sampling is dependent. So the options you shall be looking at are A and D. You look at A, it says the sampling is dependent because an individual selected for one sample does not dictate which individual is to be in the second sample. Well, that is false, because actually how you get the second sample is from the first sample. So the first sample dictates the individuals that would be used in the second sample. So you look at D, and that is the correct answer. Then indicate whether the response variable is qualitative or quantitative. Response variable is your y. Okay, such like if you in algebra, you know that y is a function of x. In algebra, you will say that your y is the dependent variable, and then your x is the independent variable. So in statistics, the y is what we call the response variable. and then the x, we call x the explanatory or predictor variable. Then when we talk about qualitative and quantitative, qualitative is excuse me, something that deals with nominal, name, gender, religion. Okay, those are qualitative, something you cannot count or measure. If you can count it or measure it, okay, that means it deals with number, then that is quantitative. The mental health inventory, you ask yourself, can you count it? Can you measure it? Or is it more of qualitative? Like maybe the blood group, the genotype, you know. So in this case, we don't know the mental health, like we don't know everything specified in the mental health inventory. But we do know that from the options that are given to us, it talks about classifying the individual, and then it talks about numerical measure. So in this case, when we take a mental health inventory, it kind of classifies the individual. Okay, you know, it's a lot of factors that you take in an inventory. Some of those factors probably are quantitative, but all in all, that inventory classifies the individual. So let's go with this option that it is qualitative, okay, because it classifies the individual. Let's go with that. Okay. I hope you kind of understand these explanations. If you don't understand it, just let me know. Question 2. An educator wants to determine whether a new curriculum significantly improves standardized test scores for 4th grade students. She randomly divides 70 4th graders into 2 groups. Group 1 is taught using the new curriculum, while Group 2 is taught using the traditional curriculum. At the end of the school year, both groups are given the standardized test, and the mean scores are compared. Determine whether the sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative. In this case, you see that she randomly divides the 70 4th graders into 2 groups. Group 1 is taught using the new curriculum. Group 2 is taught using the traditional curriculum. So both events can occur without one depending on the other. Both events can occur independently. One must not occur before the other one occurs, just like we saw in question 1. So in this case, the sampling is independent because the individuals selected in one sample do not detect what individuals are to be in the second sample. So that is D. Okay. Then the response variable. Here we are dealing with test scores. Test scores are quantitative. Okay, so it's a numerical measure. So here the answer is also D. Question 3. Conduct a test at the 5% level of significance. Alpha 0.05 means 5% level of significance by determining A, the null and alternative hypothesis, B, the test statistic, C, the p-value. Assume the samples were obtained independently from a large population using simple random sampling. Test whether P1 is greater than P2, and they give you the sample data. So let us assume, okay, let's assume that in that all the questions in this homework assignment met the requirements for hypothesis testing. Okay, let us assume that all the questions here in this homework assignment met those requirements. However, you know, well, this is your assignment, and actually all of them met it. Okay, but however, they, you know, before you solve problems in statistics, whenever you solve problems with the inferential statistics, hypothesis testing, you want to make sure that the requirements are met for any questions that are asked. Okay, you want to make sure first that all the requirements are met before you now use the formulas. So, but for this homework assignment, all the requirements have been met for all the questions. So, of course, the null will be that the first population proportion will be the second population proportion, P1 equal to P2. An alternative will now be this, P1 greater than P2. So this is this here, C. Okay, the null is always that both of them are equal. And then alternative, you see this is greater than. So this is a one-tailed test, right-tailed. Okay, one-tailed test, right-tailed. Determine the test statistic. So I'm just gonna pull up. I will do this with my calculator. We will do it with my calculator, and then we will do it with Statcrunch. Okay. So just type in my name, Samuel Chukwemeka AppSpot. Let's use the mobile-friendly site. Portfolios. You can also get this in statistics resources. You can. And then hypothesis testing calculator. Okay, so in this particular one question, determine the test statistic. Okay, these two sample. And this is right-tailed. If you look at this alternative hypothesis, P1 greater than P2. So that's right-tailed. So you come here, you click on this, two samples right-tailed. Let's get this to be side by side so you can see it. Okay, so X1 is 122, N1 is 252, X2 is 136, and 2 is 306. And the level of significance is 0.05. Please make sure you select decimal. Okay, you select decimal. Now if you want, you can put 5 and you put percent. It will give you the same thing. And you click calculate. Okay, you scroll down to see that the test statistic is 0 round to 2 decimal places. So this will be 0.94, the test statistic, 0.94. Okay, and the p-value, 3 decimal places, p-value will be 0.174, 0.174. Okay, and the result of the hypothesis, do not reject the null. Please, you can take this down. You can kind of take down this note. When the test statistic is less than the critical Z or critical T, then do not reject the null. Also, if the p-value is greater than alpha, okay, if the probability value, the p-value, is greater than the level of significance, that's your alpha, do not reject the null. So we are looking at options A and C. And you don't, this is a conclusion, there is not sufficient evidence to support the test. And the test is this, P1 greater than P2. So do not reject the null because there is not sufficient evidence to conclude that P1 is greater than P2. So that is A. Okay? Before we go to next question, let's quickly do this. How would you do this same question with Statcrunch? Go to question help, Statcrunch. And with Statcrunch, yeah, you just need, the one thing is with my calculator, I try to answer everything, including the conclusion. But you might need to take, if you're going to do this with Statcrunch, you need to take down notes on for your decision and your conclusion. Decision is whether to reject the null hypothesis or to fail to reject the null hypothesis. And then your conclusion will be, is there sufficient evidence or not sufficient evidence? So if you're doing this same question with Statcrunch, this is what you do. You go to Stat, you go to Proportion Stats. Proportion Stats to sample with summary. To sample with summary. Okay, let me show you again. You go to Stats, Proportion Stats to sample with summary. Successes here, this is 122. The next one is 252, the sample size, population 1, a sample size of from population 1. And then the second one, number of individuals with the specified characteristics is 136. Sample size from population 2 is 306. And you want to test this. This is right-tailed. So you want to make sure this is hypothesis test for P1 minus P2. Of course, this is the null, P1 equal to P2. And the alternative, this is not equal to. You want to set this to greater than. Okay, because P1 is greater than P2. You want to do that. Because if you move this minus P2 to the right hand side, it will be P1 greater than P2. So you really want to make sure you select greater than here, and you just click compute. And when you do that, you see that the test statistic here is this stat is 0.94. That was what we got. And then the p-value is 0.174. I mean, I know here it says, I know here you can use 0.175. If you put 0.175, it will still grade it right. Okay, so that is how you do this with Statcrunch. Next question. Question 4. Construct a confidence interval for P1 minus P2, the population proportion 1 minus population proportion 2 at the given level of confidence. So we're going to do this two ways. I'll do it with my calculator. We'll do it with my calculator, and then we do it with Statcrunch. So this is a confidence interval P1 minus P2. So back on this calculator, close this here. This will be two samples, confidence interval. This is where you click. Okay, so let's get this to be side by side. Okay, x1 is 379, n1 is 526, x2 is 423, n2 is 586, and 95% confidence. So you put 95, come here and you select percent, and you click calculate, and just scroll down to see it. So this is what you're going to look for here. The 95% confidence interval is, okay, this is what we're looking for here. So you put round to 3 decimal places. So this is negative 0.054. Okay, negative 0.054, and that's the lower confidence limit, and the upper confidence limit is 0.052. 51, I'm sorry, 51. Okay, and that is it. That is it. Check answer. Okay, let's do this same question with your Statcrunch. So if you're doing it with Statcrunch, this is what you do. Question help, open up Statcrunch. Then go to stats, proportion stats, to sample with summary. Okay, to sample, proportion stats, to sample with summary. x1 is 379, and 1 sample size 1 is 526, x2 is 423, and 2 is 586. Then perform, you're not performing hypothesis tests for P1 minus P2. You want to construct a confidence interval for P1 minus P2. So you check this box. And once you check it, you make sure that the confidence interval is, the confidence level, right now it is 0.95, which is 95%. So you're good. Okay, and then you click compute, and it gives you the lower limit and the upper limits. Same thing. Okay, that is how you do it with Statcrunch. Do you understand it? Okay, next one, question 5. In a clinical trial of a vaccine, 10,000 children were randomly divided into 2 groups. The subjects in group 1, which is the experimental group, were given the vaccine, while the subjects in group 2, the control group, were given a placebo. Of the 5,000 children in the experimental group, 87 developed the disease. Of the 5,000 children in the control group, 116 developed the disease. Determine whether the proportion of subjects in the experimental group who contracted the disease is less than the proportion of subjects in the control group who contracted the disease at the 1% level of significance. So this, just like saying P1 is less than P2, P1 being the experimental group and P2 being the control group. So, of course, the null would be that P1 is equal to P2. But the alternative hypothesis would be that P1 is less than P2. So that is option B. Okay? Determine the test statistic. So this is a one-tailed, left-tailed, one-tailed, left-tailed. Okay? I'm going to use my calculator and do it, and then I can show you with Statcrunch. So with the calculator, you look at two samples left-tailed. Okay, that's what you use. X1 experimental. X1 is 87. Sample 1 is 5,000 people. Then X2, the placebo, is 116. Sample 2 is 5,000. Okay. Level of significance is where did they, let's see, yeah, I was looking for this at the 0.01 level of significance. So 0.01 decimal. Okay, calculate. So the test statistic is negative 2.06. Okay, negative 2.06. Then the p-value is p-value round to 3 decimal places, 0.0196. So you can say 0.020 because 0.019, then 6, call it 1. 1 plus 19 is 20. 0.020. Okay, that's a p-value. Okay, and the result of the hypothesis test, do not reject the null. There is not sufficient evidence to support the test. So we're looking at options A and B. Options A and B. Do not reject the null because there is sufficient evidence. That's for A. No. So B, do not reject the null hypothesis because there is not sufficient evidence to conclude that the proportion of subjects in the experimental group who contracted the disease is less than the proportion of subjects in the control group at 1% significance level. So that is option B. Okay. Let me quickly show you this with your Statcrunch. Question 5. If you're doing it with Statcrunch, question help, Statcrunch. You go to start, proportion stats, 2 sample with summary. Okay, 2 sample with summary. First one, this is 87. Observations is 5,000. Next one will be, I think that's 116, right? Yeah, 116. Observations 5,000. And in this case, you're doing hypothesis test, but this is the left-tailed, one-tailed left-tailed. So you click here and you select less than. Okay, click here, this drop down, and you select less than, and you click compute, and you will notice here that the z-stat, the test statistic, is negative 2.06, and then the p-value is 0.0199, which is 0.020, rounding to 3 decimal places. Okay, that's how you do it with Statcrunch. Question 6. A researcher wants to show the mean from population 1 is less than the mean from population 2 in matched pairs data. If the observations from sample 1 are X subscript I and the observations from sample 2 are Y subscript I, and then D subscript I is equal to X subscript I minus Y subscript I, then the null hypothesis will be that the difference, that of course H naught, which is the null hypothesis, H naught, is that the difference, which is X subscript I minus the mean of the difference. Okay, that the mean is 0, which means there is no difference in the mean of both samples. Okay, that's what it means. That the null hypothesis is that the mean of the first sample is equal to the mean of the second sample, or you can say that the mean of the difference is 0. Okay, there's no difference in the two means, in the means of both samples. Alternative hypothesis is what you want to test. You want to test that the mean from population 1 is less than the mean from population 2. Okay, so the population mean. Okay, so the null hypothesis is that the population mean is the same. The population means are the same. Okay, not the sample means. No, remember the hypothesis is about a parameter, population. Okay, so null hypothesis is that the population mean of first population and the population mean from second population, that both population means are the same. In other words, the difference is 0, which means they're the same. Alternative is actually what you want to show, what you want to test, the claim that the population mean from first population is less than the population mean from second population. So alternative would be that mu 1 is less than mu 2. Okay, so in that case, if you do that, that means that mu 1 minus mu 2 will be less than 0. Okay, so this is less than 0 because this is mu 1. Mu is the population mean. Okay, remember, alternative is that mu 1 is less than mu 2. But if you now want to have an inequality to 0, if you want the 0 to be on the right hand side, okay, if mu 1 is less than mu 2, that means that mu 1 minus mu 2 is less than 0. Okay, that's the mean of that difference is less than 0. That's what it means. Okay. You can look at this instructor tip later on. Question 7. The following data represent the muzzle velocity in feet per second of shells fired from a 155mm gun. For each shell, 2 measurements of the velocity were recorded using 2 different measuring devices, resulting in the following data. So you've seen the data there. Why are these matched pairs data? So this data first is muzzle velocity of shells fired from one gun. Okay, the muzzle velocity. So, but down for each shell, they recorded 2 measurements of the velocity, even though they recorded it with 2 different measuring devices. It doesn't matter. Okay, just know that the measurements were taken on the same round. Okay, for each shell, 2 measurements were recorded. So these are matched pairs data because the measurements are taken on the same round. Okay. Next one. Is there a difference in the measurement of the muzzle velocity between device A and device B at 1% significance level? Note, a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. What is your conclusion regarding the null hypothesis? Okay, of course, the null hypothesis is that there is no difference. That's the null hypothesis. The null hypothesis is that there is no difference. So, but they want us to state the conclusion. But we have to test it. We cannot just state conclusion without having to test it. So this is what I'm gonna do. You go to Statcrunch. Actually, don't open it here. Okay. The easiest way is you click on this here and click open in Statcrunch. We are going to test because for us to make our conclusion, we have to do the testing, find our decision, then our decision will now enable us to make our conclusion. So actually, this is what they're asking. This is decision, whether to reject the null or fail to reject the null, which means do not reject the null hypothesis. But let's first of all test it first. Okay, so these are matched pairs data. So you go to stats, go to t-stats. When you are giving, this is not a proportion anymore. Okay, so when you're giving the sample data, okay, you're not giving the population standard deviation. You're not giving any. If you're not giving population standard deviation, okay, you have to use t-stats. You have to. Now, if you're giving population standard deviation, you use z-stats. But if you're not giving population standard deviation, like here they gave us just samples, they didn't give us any population standard deviation. Now, they told us it met the requirements that the population is normally distributed. Like I said earlier, we are going to assume all the questions here meet the requirements, okay? So, because they did not give us the population standard deviation, we have to use t-stats. So, you point your mouse at t-stats, you get paired, okay? Sample 1 is your A. Please note the observation. Your sample 1 is your A. Sample 2 is your B. And we want to, the question they ask us is there a difference? Okay, is there a difference in the measurement at this level of significance? So we can, we are going to, in this case, they just ask us is there a difference? So we're going to leave this here because not equal to means that there is difference. Okay, this null is that there is no difference. Okay, mu A is equal to mu B. So mu A minus mu B will give you 0, which is the mu of the difference. So the null is that there is no difference. Alternative is that there's a difference. They didn't ask us whether it is less than or greater than. So we're going to leave it as not equal to. Okay? And we just click compute. So here, you can use the, I want you to really understand this hypothesis testing. So I'm going to explain, I'm going to explain it. Okay. We can use p-value here. They gave us, we can use p-value approach. They gave us the level of significance, which is 1%, 0.01. P-value is 0.673. 0.3738. So you can take this down in your notes. If you're using p-value approach, if the p-value is less than or equal to the level of significance, reject the null hypothesis. I repeat, if the p-value is less than or equal to the level of significance, reject the null hypothesis. If the p-value is greater than the level of significance, then do not reject the null hypothesis. If you look at this here, the p-value is 0.6738. It is greater than the level of significance, 0.01. So do not reject the null. Do not. Okay? Then the next one, they said construct a 99% confidence interval about the population mean difference. Okay, so we get back to our Statcrunch. I'm going to close this result. You go to Stat again, go to T-Stats, go to Paired. Sample 1 is A, sample 2 is B. In this case, you're not performing hypothesis test. You want to construct a confidence interval. So you check this option, and this is 99%. So this, if you convert 99% to decimal, it is 0.99. And then you click compute. So the lower limit is say round to 3 decimal places. Okay. So here, lower limit is negative 9.026. Negative 9.026. And then upper limit is 7.226. Okay, enter. All right, that's it. And then interpret it. Interpretation, we've done that in previous videos. You're just 99% confident that the mean difference in measurement lies in the interval found above. That's it. Okay. Then it says here, oh, this is another one, question 8. Okay, so let's close this. We're getting there. Question 8. A researcher studies water clarity at the same location in a lake on the same dates during the course of a year and repeats the measurements on the same dates 5 years later. The researcher immerses a weighted disc painted black and white and measures the depth in inches at which it is no longer visible. The collected data is given in the table below. So we have this data here, and it says here, why is it important to take the measurements on the same date? If you first of all look at this data now, this is the matched pairs data. It's matched pairs. Matched pairs is when you have samples and there is a relationship between those samples, and for it is dependent. It has a relationship. It is either dependent or it has a relationship. Or you're taking the same, you're looking for the same measurement, but you're doing it on different dates. You're going to use matched pairs data. Okay? And of course, like I said, if you're not given the population standard deviation, you have to use T-stats. Now, if important to take the measurements on the same date is that if you use the same date, that means you're making the second sample dependent on the first. Okay, that is if using the same date, it makes the second sample to be dependent on the first. Remember, you're taking the first measurement, measuring water clarity at the same location, then this is the initial measurement. But if you wait till 5 years before you repeat the measurement, that's what he did here. After 5 years, he repeated the measurement. But if you take it on the same date, that means like having your second sample depending on the first. You first of all take the first sample, then you now measure it again, measure the water clarity again to get the second sample. So using the same dates actually makes the second sample dependent on the first. Okay. Does the evidence suggest that the clarity of the lake is improving at the 5% level of significance? And then note that the normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. Okay, so even though this was done after 5 years, it is still matched pairs. It's still the same. It's just you're measuring water clarity. That's the main thing. That's the measurement. It's just that you did it in 2 different dates. So we shall still consider this as matched pairs. We're going to run a t-test just like we did in the previous question. Get Statcrunch. Actually, you know what? Let's get it from here. Okay? It's much easier getting it from this tip. Open in Statcrunch. Starts paired. Okay, paired. First sample one is the initial observation, and then the second is after 5 years. Okay, initial measurement, and then the second sample. First sample is the initial measurements. Second sample are the measurements after 5 years. You want to, they said, does this suggest that the clarity of the lake is improving at this level of significance? So we will just test the hypothesis. We don't know, the null is that is the same. Okay, alternative not equal to 0 means that it's not the same. So it's not the same means that the initial is probably better than the measurement after 5 years, or that the initial measurements are not better than the measurements after 5 years. So we just leave it like this and we click compute. Okay, we get our p-value. Our p-value is 0.7707, and the level of significance is 0.05. So we see that our p-value is greater than the level of significance. So we do not reject the null. We don't reject it. Okay. Okay, so I think question 8 is gone. Question 9. Later you can review these videos. A researcher randomly selects 6 fathers who have adult sons and records the fathers and sons' heights to obtain the data below. Determine if sons are taller than their fathers at the this is 0.1, 10% level of significance. Okay, this is 10%, which is 0.1 level of significance. So the normal probability plot and box plot indicate that the differences are approximately normally distributed with no outliers. This here, there is a relationship. Okay, you want to find out if the sons are taller than their fathers. The first height the first one are the heights of the father, and the second one are the heights of the sons. Okay, heights of the fathers, first one, okay, and then heights of the sons, second one. And this is a sample. This is also a matched pairs sample. Okay, so we're gonna use t-stars matched pairs for this question as well. There is a relationship between the samples, so it's matched pairs. Okay, here using the differences father's height minus son's height, what is your conclusion regarding H naught? H naught is your null hypothesis. We have to run the test first. Okay, we have to run it first. Remember, the height of the father is mu, let's call this mu1. Height of the sons, mu2. Mu is the population mean. Okay, so mu1, mu2. So H naught will be that mu1 is equal to mu2. That is H naught. H1, the alternative hypothesis, is that mu2 is greater than mu1. Determine if the sons are taller than their fathers. So if mu2 is greater than mu1, so mu2 greater than mu1 means that mu1 is less than mu2. Okay, mu2 greater than mu1 means that mu1 is less than mu2. So it means mu1 minus mu2 is less than 0, because mu1 has to come first, folks. Okay, I really want you to take what I'm explaining down. Mu1 has to come first. So determine if sons are taller than their dad, are taller than their fathers, means mu2 greater than mu1, but mu1 has to come first. So if mu2 is greater than mu1, that means that mu1 is less than mu2. Okay, and then that means that mu1 minus mu2 is less than 0. Okay, so we open this in Statcrunch. So this is a one-tailed test, left-tailed. I see here they want us to test this using the classical approach. Okay, we are going, don't worry, we're gonna do it with both. We are gonna do it with both. We will do it with p-value, and we'll also do it with classical approach. So p-value is usually easiest anyway with technology, but I'm gonna show you also with classical approach. All right, we've opened this. Go to Start, T-stars, Paired. First one is the height of father, sample 1. Second one are height of son. You want, in this case, the difference mu1 minus mu2 is less than 0. Okay, so it is one-tailed and it is left-tailed. Okay, and you click compute. So let me first of all, p-value is easiest first. So let's do this first with p-value, and then we will do it with t-stat. Okay, so p-value approach, we see here that our p-value is 0.0964. Okay, compare this p-value with the level of significance, 0.1. Who is greater? So you see that 0.1 is greater than 0.0964. So, or you can say 0.0964 is less than 0.1. Okay, so if p-value is less than or equal to level of significance, reject the null. So our conclusion is reject the null hypothesis, period. So we're going to look at these two options. Our decision will be to reject the null, period. But now, as you can see, they are asking us this so that we could use classical approach, not the p-value. Okay, now take this note down with classical approach. For left-tailed test, okay, if the test statistic, which is T naught, okay, if the test statistic is less than the critical T is T alpha, reject the null. Okay, so already the answer would be D. Okay, just by doing p-value. P-value is less than or equal to level of significance. You have to reject the null. But then, from what I just said now, okay, if you're using the classical approach, you reject the null if the test statistic is less than the critical T. But now, let's also verify that. Before I check the option D, let's verify that. So T start right here, and this is for left tail test, okay? This is for left tail test. Now, T start right here is negative 1.504299. That is T naught. That's the test statistic. Okay, let's find our critical T. Remember, this is a one-tail test. Let's find our critical T, and then we compare. So I'm going to close this. I open this again, open in Statcrunch. Go to Stats, go to Calculators, go to T. Degrees of freedom, because this is a mean, just the one parameter is what we're measuring. So degrees of freedom is n minus 1. The sample size is 6. 6 minus 1 is 5. So degrees of freedom is 5. And the level of significance is 0.1. So I'll put here 0.1. And this is, we want one-tail test. So you leave it like this. Compute. So this gives us negative 1.475884. So you compare negative 1.50 and then negative 1.48. If you round it to 2 decimal places, our critical T is negative 1.48. Our test statistic is negative 1.5. So we see negative 1.5, of course, is less than, it falls in that region, is less than the critical T. Negative 1.5 is less than negative 1.48. Okay? And because it's less than that, because it falls in that region for one tail, for left tail, okay, because it's less than that, we say we're going to reject the null. Okay? So this is reject the null because of that. So that is classical approach. Okay, question 10. Assuming that both populations are normally distributed, construct a 95% confidence interval about the difference in the mean, in the population mean. Okay, mu1 is the mean of the experimental group, and mu2 is the mean of the control group. So in this question, both groups are independent. You have the experimental group, you have the control group. So these are independent. So these samples are not matched pairs. They are not. Okay, they are not matched pairs. So, but you know, they did not give us the population standard deviation. So we will still use our T stats. Okay. And of course, the requirement, both populations are normally distributed. So we're gonna get the Statcrunch. We really wanna kind of minimize, make sure we see this side by side. Okay, I hope this is really making sense to you. Yeah, I really hope so. Okay. We're gonna go to stats. Please, I really want you to pay attention for this question. These are not matched pairs anymore. These are independent samples, and they want us to construct in a confidence interval about the difference in the mean of both samples. So go to start. We're gonna use t stats to sample. Okay, because these are two samples. Don't use paired this time. This is two sample, and this is with summary because this is not data. So you click with summary. Okay. So sample 1, the mean is 46.1. The standard deviation is 5.6. The sample size is 26. Sample 2, the mean is 47.1. The standard deviation is 11.9. And the sample size is 25. You see both of them do not have the same sample size. That's fine. They are independent samples anyway. Please make sure that you uncheck this pool variances. We don't want that. So uncheck this, uncheck that box, and then perform confidence interval. That's all we want. And 95%, which is 0.95. So we have that. And then click compute. And here is your lower bound is negative 6 point, round to 2 decimal places. So this is negative 6.33. Okay, and this is 4.33. Okay. Okay. Next question. Let's go ahead and close this. Question 11. Test whether the mu1 is less than mu2 at 0.02 level of significance level. This is 2% significance level. For the sample data shown in the table, assume the populations are normally distributed. So the null, of course, is that the mu1 is equal to mu2. Alternative is that mu1 is less than mu2. So this is one-tailed, left-tailed. Okay, one-tailed, left-tailed. So the option here will be D. Okay. Determine the p-value. So we did this. I'm gonna click on the table. So this is the table here. Let's minimize this. Get the Statcrunch. Okay, so these are two different populations. They even have two different samples. Two different samples. Okay, from two different populations that are normally distributed. So these are independent samples. Okay, so they did not give us the population standard deviation, so we're gonna use t-stats. So t-stats to sample with summary. This is summary. Sample mean for the first sample from population 1 is 103.4. Standard deviation 12.2. Sample size 31. Sample mean here is 114.5. Standard deviation 13.2. Sample size 25. Make sure you uncheck this pool variances. Uncheck it, please. And what do they want us to do now? They want us to determine the p-value for the hypothesis test. So they are not asking for confidence interval. They are not. they are asking for hypothesis test. Okay, so the null is mu1 minus mu2 is 0. Alternative is mu1 less than mu2, which means mu1 minus mu2 is less than 0. Less than 0. Okay, and that makes it one-tailed, left-tailed. And you just click compute. If you kind of scroll here, so the p-value round to 3 decimal places, which is 0.001 is the p-value. Okay, and then what should be your conclusion? P-value, this 0.001, compare it with the level of significance 0.02. So p-value is less than alpha, okay, which is level of significance. 0.001 is less than 0.02. So because if the p-value is less than or equal to the level of significance, reject the null. Excuse me. Reject the null. So we are looking at B and D. Okay, we're looking at B and D. Now, once you reject the null, anytime you reject null, you know, in this case, you say, okay, there is sufficient evidence to conclude the test. Okay, now, if you do not reject the null, that means there is not sufficient evidence to conclude the test, to support the test. But whenever you reject the null, that means there is sufficient evidence to support the test. So you look at B and D, you see for D, reject the null, there is sufficient evidence at the 2% level of significance to support this, that mu1 is less than mu2. Okay, so that's it. Okay. Question 12. In baseball, how many of you play baseball? In baseball, League A allows a designated hitter to bat for the pitcher, which is typically a weak hitter. In League B, the pitcher must bat. The common belief is that this results in League A teams scoring more runs. In interleague play, when League A teams visit League B teams, the League A pitcher must bat. So, if the designated hitter does result in more runs, it would be expected that League A teams will score fewer runs when visiting League B parks. To test this claim, a random sample of runs scored by League A teams with and without their designated hitter is given in the accompanying table. Does the designated hitter result in more runs scored at the 5% level of significance? Okay, so if you look at this now, it says here, click the icon to view the data table. Okay, so we have this. So you ask yourself, is this matched pairs or independent? Okay, as you can see here, these are just independent. One with the designated hitter, one without the designated hitter. First of all, let's answer this. So the null is that there is no the runs are the same. That's the null. Mu A is equal to mu B. But then the alternative will be, does the designated hitter result in more runs? So the alternative hypothesis will be that mu A is greater than mu B. Or you can say mu A minus mu B is greater than 0. And this would be one-tailed, right-tailed. Okay? So the option is C. Okay? Determine the p-value for this test. So we're gonna get our Statcrunch. Okay, you go to start, t-stats, to sample with summary. First one, sample mean for the A. First one is for A. This is 6.0 or 6. Standard deviation is 3.5. And then the size. Let's get the size. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 30. So both of them are 30, 30. Okay? 30. Sample mean for B is 4.3. Sample standard deviation is 2.6. Size is 30. Okay. I just want to check these pool variances. And we want to get the p-value. This here alternative will be that mu A minus mu B is greater than 0. Okay, that is greater than 0. That is one sample. I'm sorry, not one sample. One-tailed, right-tailed. Okay, one-tailed, right-tailed. And you click compute. Scroll here. The p-value to 3 decimal places would be 0.019. Okay, 0.019. Okay. Now check your the 0.0187 and the level of significance 0.05. So which one is greater? Okay, as you can see, 0.05 is greater than 0.019. Okay, 0.05 is greater. So because that means that the p-value is less than, the level of significance is greater than the p-value, which means that the p-value is less than the level of significance. And if the p-value is less than or equal to the level of significance, reject the null. So we're going to look at option C and D. Reject the null. Okay, when you reject the null, that means there is sufficient evidence to conclude that the games played with a designated hitter result in more runs. Okay. Okay, almost getting there. Question 13. A random sample of 40 adults with no children under the age of 18 years results in a mean daily leisure time of 5.97 hours with a standard deviation of 2.46 hours. A random sample of 40 adults with children under the age of 18 results in a mean daily leisure time of 4.49 hours with a standard deviation of 1.57 hours. Construct and interpret a 95% confidence interval for the mean difference in leisure time between adults with no children and adults with children. Okay, so in this case, these are independent samples. One is with children, one is with no children, the other one is with children. And because we were not given population standard deviation, what we are given is sample standard deviation because it's a random sample. We're going to use t-stats, okay, 2 samples. So let's get our Statcrunch. T-stats to sample with summary. So first sample mean, first sample is with no children. Mean is 5.97. Standard deviation is 2.46. And the sample size is 40. Second sample mean is 4.49. Standard deviation is 1.57. Sample size is 40. Okay, I'm gonna check this. Then here we are performing confidence interval. Okay, we are performing confidence interval, and this 95%, so 0.95. If they ask 99%, you put 0.99. Okay, so but they asked for 95% confidence interval, and we just click compute. So we get our lower limits, lower confidence limit, and upper confidence limit. 2 decimal places, so this will be 0.56 for the lower one, and for the upper will be 2.40. Okay. Continue. Interpretation means that there is not, we did confidence interval in the previous assignment. So in this interpretation, we are 95% confident that the difference of the means is in the interval. Okay, difference of the means is in the interval, and then you conclude that there is a significant difference in the number of leisure hours. So our answer is A. Okay. Question 14, last but not the least. Later you can look at this. A physical therapist wanted to know whether the mean step pulse of men was less than the mean step pulse of women. She randomly selected 59 men and 79 women to participate in the study. Each subject was required to step up and down a 6-inch platform. The pulse of each subject was then recorded. The following results were obtained. So they gave us these. So this is like they've run the test and we just have to answer these questions. So null is that the mean 1 is equal to the mean 2. Mu 1 is equal to mu 2. And what did he want to know? He wanted to know whether the mean step pulse of men was less. So alternative would be mu 1. Mu 1 is for the men. Mu 2 is for the women. So alternative would be that mu 1 is less than mu 2. And that is one-tailed, left-tailed. So the option here is C. Okay. P-value, identify the p-value. They wrote it here already for us. Okay, identify the p-value and state the researcher's conclusion if the level of significance was 2%. What is the p-value? So they wrote it right here, and that is 0.0027. Okay. State the researcher's conclusion. Which of the following is correct? So the p-value is 0.0027. The level of significance is 0.02. So we see that the p-value is less than the level of significance. Okay, and if the p-value is less than or equal to the level of significance, you reject the null. So we are looking at options A and B. So when you reject the null, that means there is sufficient evidence to conclude that the test, there is sufficient evidence to support the test, which means there is sufficient evidence to conclude that the mean step pulse of men was less than the mean step pulse of women. So the option is B. Okay. What is the 98% confidence interval for the mean difference in pulse rates of men versus women? And you see here, they wrote it here, 98% confidence interval for mu. Mu men minus mu women. Excuse me. So round to 2 decimal places as needed. So this is negative 11.40 and negative 1.00. Okay. Interpret this result. We are 98% confident that the means are in the confidence interval. And then you see here, look at B and C. You have to be careful in B and C. Okay, you're 98% confident that the mean difference is in the confidence interval. Okay, not that the means are in the confidence interval, but the mean difference is in the confidence interval. Remember, the hypothesis is that the null is that the mean difference is 0. Okay, mu1 is equal to mu2. Okay, so we're looking at mean difference. So B. Okay. Okay, that is it for tonight. Thank you so much for listening to this video presentation. If you have any questions, please feel free to ask me. And you have a good night.